Our team was able to meet the requirements for the previous design challenge by producing functioning measuring tapes within the assigned tack time. However, there were obvious flaws in both the assembly process and the parts received from the manufacturer. The springs became extremely warped after multiple assemblies, the small pieces were hard to distinguish between, and the layout of the assembly line was not ideal. These, amongst other things, were the problems we aimed to solve or improve in this project. We first explored how to improve our 4-workstation solution. Then, we refined the process into a 3-station line using research on improvements we could make into a real-world scenario. We used well-tested manufacturing techniques to improve our process, including 6S, total quality management, and single-minute exchange of dies. 6S is a common technique for improving manufacturing processes. After researching the principles of 6S, we used the methods that applied best to our process. The 6S process was developed in Japan and is roughly translated into 6 steps. Sort, which is reviewing the work area and eliminating any unnecessary tools or materials. Set in order, where all the items left over are given designated locations based on frequency of use and where in the process it's needed. Signs and labels are useful in ensuring tools are put back into their designated locations. This step focuses on the layout of workstations and how to remove extra motion and unnecessary transportation. Shine is centered around housekeeping, cleaning workstations, and performing routine maintenance. Standardize is where all the improvements from the first 3 stages are kept up by creating schedules and standard operating procedures. Sustain focuses on maintaining the previous improvements and updating them as necessary. Safety is an aspect not in every procedure, but it's focused on arranging the tools and equipment to improve the safety of the worker. It focuses on improving ergonomics by reducing strenuous or highly repetitive manual tasks. The main benefits of implementing 6S are higher quality products, increased productivity, greater employee satisfaction, and a safer working environment. Following the 6S principles, we focused on sort, set in order, and safety. We reviewed the 4 workstations we had come up with originally and determined if there was any unnecessary equipment. We removed excess screwdrivers that were cluttering workstations 3 and 4. Then we changed the layout of our assembly line. Previously, our 4-person process was arranged around a single table with 2 people on each side. This forced Station 2 to reach over their parts and Station 3's parts to pass the product along. This was remedied by changing the formation into a single line, with each station passing to the right. This arrangement is more efficient as the product needs to travel less distance and is safer and more comfortable and sustainable for the worker at Station 2 as they stay within their normal reach.
In this stage, we also grouped alike pieces into bins and labeled them so they could be easily identified. Then we arranged the bins into their respective workstations and put them in left to right order of how they are assembled in the product. Following the SMED principle of reducing change over time, the bins also allow for workers to restock their part supplies more easily and less frequently. For this project, we found we needed 4 small bins, 1 medium bin, and 3 large bins at a total cost of $138.96, which is an acceptable cost for the time it saves in the manufacturing process. Another considerable problem with this design is the similarity of the small screws. Even when sorted into bins, it is quite hard to tell them apart and remember where they go. We solved this by color-coding the threading of the screws and the inside bevel of the holes to allow the worker to easily identify where the screws go. The decision to color the threading versus the head of the screw comes from total quality management theory. The customer experience with our product is improved by the overall aesthetics, so by coloring the threading, it won't be visible to the consumer once assembled. Additional improvements were made on the clip assembly by marking the back of the clip to indicate which side should face down and tracing the clip so the worker can easily align the clip in the correct place. The clip has no physical barriers to prevent it from sliding before the screw is placed, therefore visual cues are a helpful tool to lower the station's work time. The spring placement task has been quite troublesome in this project. When the springs are new, as they would be when assembling measuring tapes using new parts each time, we found that long needle nose pliers were the optimal tool for assisting with the placement of the spring into the lower casing. All of these improvements were made with the main goal of reducing our cycle time and variation.
We performed a statistical analysis on the 4-workstation solution and the 3-workstation solution to determine if the changes caused a significant improvement. For each solution, we performed 30 time trials before and after the improvements were implemented. For the 4-workstation solution, we tested if the mean and the variance were reduced after the changes were executed. The mean assembly time and variance in assembly time were calculated before and after. A paired t-test was used to determine if there was a difference in the means, and an f-test was used to determine if there was a difference in the variances. At 95% confidence, the mean was statistically smaller after the improvements. However, the variance did not change. In conclusion, the 6S improvements had little impact on assembly time, but there are immeasurable benefits such as improving worker ergonomics.
Many of the parts required for building the measuring tapes were of poor quality. 2 ways to address this issue would be to order a different set of components and contact the supplier with requests to change parts. Firstly, we would order 2 identical small screws for the center clip and right side to reduce sorting confusion during assembly and remove need for separate screw bins. We would ask the supplier for a deeper groove to be carved into the front casing to prevent the clip from shifting after being placed. This would also negate the need for the clip to be traced. The supplier would also need to ship the tapes individually packaged to prevent them from unraveling before being placed inside the lower case. With regards to tool use, we would also invest in a magnetic electric screwdriver. In our old workstation arrangement, we were hoping to have all the screwing done on a single station, since this would lower the cost of buying screwdrivers and simplify the tasks assigned to a single worker. However, by using manual screwdrivers, it was not possible to have one person do all 3 tasks and stay within tack time, so the screwing was split between stations 3 and 4. When the opportunity to make improvements arrived, we decided to test out the idea of using an electric magnetic screwdriver. Electric screwdrivers that spin at 1500 RPM are easily available and cost less than $100. When we simulated the time a worker would complete tasks with the electric screwdriver, an average of 27.8 seconds were saved. We also found the variance in times with the electric screwdriver to be lower, suggesting more consistent production. Given this result, we found that we were able to reduce our assembly line to 3 stations. Reducing the workforce to 3 people saves $90 a day, or $22,410 annually. We will also save in future costs related to workplace injury due to repetitive tasks such as wrist movements required for screw driving. Therefore, the cost of the electric screwdriver is financially justified.
We performed the same tests on the mean and variance for the 3-workstation solution. The mean assembly time and variance in assembly time were calculated before and after the changes were implemented. Again, a paired t-test was used to determine if there was a difference in the means, and an f-test was used to determine if there was a difference in variances. At 95% confidence, the mean and variance were statistically smaller after the changes were completed. In conclusion, this solution greatly reduced the mean assembly time and the variance in assembly time. This results in more consistent production output and the flexibility to meet a higher demand.
With implementation of new tools, 6S principles, and the new workstation layout, there are many financial benefits related to reducing production time variations and improving material flow. Thanks for watching.